Sets can be represented using diagrams known as Venn diagrams, after the name of John Venn, who was a mathematical logician. He came up with the idea of representing sets using diagrams. There was another mathematical logician called Charles Dodson, who also came up with a similar concept. He called it logic diagrams. The only difference is that his sets were not circles, they were rectangles all the way. Charles Dodson is commonly known as to the reader as Lewis Carroll because he wrote Alice in Wonderland. Now this is how Venn diagrams work. The rectangle represent the universal set. The circles represent the subsets, the regular sets. Now the two special relationship of the sets are the subsets are written one set inside another set. So A is a subset of B. That would be represented using the Venn diagram where we have a universal set and inside the set B we have another set. Now the null set relationship would be represented as two sets further away. So A intersection B null set, meaning A and B do not intersect. They are given by this diagram where the sets are further apart. So in a Venn diagram we can represented relationships of sets and also the sets, and their used primary tool is a rectangle for the universal set and a circle for the sets. The first one, A union B. So to show A union B, the sets are shaded. So we take this set and A and B and we shade it. So A union B is this region. All this region is A union B. Next we have A intersection B, A intersection B. So the Venn diagram A intersection B, if this is set A, this is set B, set A, set B. So A intersection B is this common region, the region where A and B they are overlapping. Next we can show A prime, a complement set. So we have this. It doesn't matter whether we have one set or two sets. Even if you have two sets, we can show by shading the region that is A prime, that even means outside the set A. A prime means not A. So that set would be everything in the universal set except for A. So A is removed from the universal set. Now apart from that, there are other sets, important relation, which is a combination of intersection and prime, which is the intersection complement set. So A intersection B prime, or it is also B intersection A prime, or it can also be A prime intersection B prime. Now A intersection B prime means from the set A, remove anything that is belonging to the set B. So if you have set A and set B, so the shaded region would be from the set A, remove everything that is in B. So this would be the shaded region. So this shaded region represents A intersection B prime. Then for B intersection A prime, so it would be the opposite. So this time what we do, we take set B and from that we remove anything that is inside set A. So this would be B intersection A prime. The next one is A prime intersection B prime. That means we remove both. So we remove both. So we have two sets. So if we remove both, that means, so the set that we write is outside either of the sets. That is A prime intersection B prime. Now, common regions of sets can be represented by other notations also, but these six, they're the basic, and you should memorize these six Venn diagrams. They come in handy a lot. Now what about three set Venn diagrams? These two set Venn diagrams are pretty straightforward. Three set Venn diagrams are a bit more difficult. Okay, so when you have a three set Venn diagram, A, B, C. So we have A, B, C. So remember, A union B union C represents the shading of all three sets. So that would be these three sets. This is A union B union C. So this is the representation of all three sets. Now intersection. So we have A, we have B, we have C. So A, B, C. So this set A intersection B intersection C, we were looking for something that is common to A, B, C, all three. So this is this region, common to all three. Now here we have to remember some the complement one also. So the complement set is going to be A, B, C. So if we want to make A prime intersection B prime intersection C prime, that means we remove everything. Intersection prime means we remove everything. So that region would be this outside. Now in three-set Venn diagram, there is some union sum that you have to remember. For example, if you have a question that is A intersection B and B intersection C union. So what you do is you remember, let me label it ABC first. A, this is A, this is B, this is C. So if A intersection B is this region and B intersection C is this region, so A intersection B union B intersection C would be these two regions shaded together. That's all. Now in the next question, if you have A intersection C union A intersection B, in that case A, B, C, the shaded region would be, so A intersection C is this region over here and A intersection B is this region over here. So you shade both and you leave it. So this is the intersection union. What about A union B intersection C? Well, A union B is both A and B completely shaded and C is this. So the common portion between, intersection means common, the common portion between A and B with C is this region. So this is the region where we will get A union B intersection C. These three set Venn diagrams have 8 special regions that is important to remember. First of all, if you take all these three, this is full set over here. These are full sets. Now when we say A is made up of 1, 4, 5, 7. So we have 1, 4, 5, 7. So this region A is made up of 4 regions, 4 separate regions, 1, 4, 5, 7. And similarly B is also made up of 4 separate regions. B is made up of 2, 5, 6, 7 and on and on. So these are the full sets. Now on the right hand side, the sets that we have the common sets. The common sets. Now the common sets have a name. For example, A intersection B or A intersection C or B intersection C, they can be used the word both. Both can be used, or the word at least. So if they use the word at least A and B, it means this region. If they use the word at least A and C, it means this region. Or if they say both A and B, it's the same thing. So these sets on the right hand side, the vocabulary used in the exam would be both or at least. So if they used A or B or C, we use the full sets, which are made up of 4 regions over here, and these regions are made up of 2 regions each. Now the main part. Now the sets which are shaded by 1, 2 and 3, these regions are called only. So this is only A, then this is only B, and this is only C. So when they talk about only, these are the regions that are being talked about. Now here exactly at the center, that region is denoted by all. So this one here at the center, that means all. This is all. All the 3 sets are common over here, region 7. So region 7 is all 3. And here it means none. None of the sets are present here. So these are none. Now the remaining 3 sets, 3 regions, 4, 5 and 6, these regions denote only. So this region means only A and B. This region over here means only A and C. And this region, region 6, denotes only B and C. So there is a major difference between only A and B, which is region 5, from at least A and B, which is this, both the region 5 and 7. Or if they mention both A and B, that also means region 5 and 7. So that is very, very important.